Hello, world. This is the Roniel and DaRon podcast show. I am Roniel,
I am DaRon.
and welcome to episode 3 of our podcast. With that being said, um, I would like to actually for you to tell people your ideology about how to solve a problem. What I mean by that is most people think when okay, I'm good at solving computer problems, right? Say I'm good at that. How do you take that same principle and apply it to other areas? And I know you have an ideology about that and how you could do that, which makes you better because in security, in one perspective, or just in anything, a lot of times you have to be a jack of all trades.
Right,
But how do you take that knowledge that you learn and apply it to other things?
right. So, one of the most important things that you can do in your field and in your life, period, is learn how to abstract everything. And that's abstract your problems and abstract the solutions. So, a lot of people go through and they're very specific and very myopic, right? So, I need to move a box. So I devise a plan to move this box. Well, moving a box, it doesn't matter if it's a box of, let's say, this size versus a box that's 2 or 3 times bigger, right? The weight doesn't necessarily make a difference until you start talking about it getting ridiculously heavy. And so people come up with very quick, specific plans. How do I move that box? Well, your brain actually knows how to move boxes of various sizes, right? And it figures that out in general and it says, okay, well, this is generally how I need to move a box. Well, now, how do I move a dog? How do I pick up a dog and move a dog? If you think about it, picking up a dog, moving a dog is very similar to how you move a box. The only difference is going to be weight and weight distribution. Well, boxes can have different weights and distributions, right? Maybe there's something in there that's sloshing around. Maybe you've got some heavy stuff on one side, but not on the other side, whatever happens to be, right? So inherently, what you do, whether or not you realize it's what you're doing, in general tasks throughout your life, is you abstract it all. You're not sitting there going, okay, well, this box is 12 feet. That's terrible. This box is 12 inches by 12 inches, and that's a square. And so I'm going to pick it up this very specific way. But the next box that's 12.5 inches by 13 inches, you have to rethink, how do I pick that up? You sit there and you're like, well, it's a box. I know how to pick up a box, right? I do this thing and poof, there goes the box. So when it comes to learning and doing anything new, what you need to do is pay attention to how the problem is similar to other things you've done. To give some good examples, let's say you're talking about you need to do, actually, very easy, security, right? What do we have? We have SQL injection. We have cross-site scripting, which is a form of client-side injection. We have server, well, we'll break this down even better. We have server-side injection and we have client-side injection, right? Those are two very high-level terms.
Right.
Now, within that, you've got tons and tons and tons and tons of different kinds of injection. The attacks themselves are not different. There's absolutely, conceptually, there is no difference between, I don't even care if I'm injecting to a backend LDAP server versus a backend SQL server versus something like remote code execution. So I'm injecting straight into your interpreter. That doesn't actually make a difference. The only thing that does is change what the keywords are, right? And the structure. But that doesn't change anything beyond that. The problem with our industry and the problem with most individuals is they think way too specifically. So they focus on, okay, how do I do SQL injection? Well, I'm going to do this and boom, SQL injection. Well, okay, that's great. How do you do LDAP injection? The process is the exact same. How do you do Solr injection? The process is the same. How do I do a remote code execution injection involving, say, PHP or Java or Perl. Again, the process is the exact same. So one of the key things that you actually have to learn to do is always pay attention to similarities and then abstract everything. There is absolutely, positively zero reason why people fixate on securing against SQL injection or securing against directory traversal or path traversal, depending on who it is you're talking to or about, or securing against really anything. Buffer overflows, same exact thing, right? So all of those are input validation issues, every single one of them. So you want to know how to really solve it? It's called properly sanitize and validate your data, right? So what are we doing? We're taking it to the highest level. And instead of having libraries and fixating on these silly myopic topics, I'm going to see the whole forest for what it is. And I'm going to solve the root underlying issue, which is that, well, I'm not properly sanitizing and validating my input before I do anything with it, whatever it is that I happen to do. That's how you're sitting there injecting DLLs onto my Windows Exchange server, right? That's how you're going through and reading random files. That's how you're going through and doing the various XML deserialization, serialization attacks, and things like XXE injection and so on and so. It's all the same silly thing, every single one of it. And one of the tricks to becoming a jack of all trades is understanding that all of the problems in the world are in general the same. And you just need to find the problems that are most similar and the solutions to those problems, and you can solve what it is you're after. So we've talked before, and it's interesting because a lot of research goes into things like blood clotting and things of that nature for the military. So a team went through and they were trying to figure out coagulation in a wound, which is apparently a seemingly complicated thing. And what they wound up finding out was that, interestingly enough, it actually matches and marries up well with the sine wave caused by a pendulum swinging. And knowing that, they were able to pick materials that actually caused coagulation much better than what was currently available. And that's similar to, so let's say your house has a leak. What do? You're going to take that spray and insulation and you inject it, right? Problem solved.
Yep.
Okay. So now let's say again, we're instead talking about the human body. And you just took a round, several rounds. Let's say you took several rounds, or maybe you took shrapnel from something exploding, whatever it happened to be. And you are hemorrhaging. And let's say it's in your torso or your leg. What is it you're really trying to stop? Are you trying to stop the hemorrhaging, which means you're trying to close a gap, or are you trying to stop that specific bleeding? We want to stop the hemorrhaging. We want to close the gap is really what we're after. We're trying to close your arteries, your blood vessels, they have a gap, right? And we need to close that gap.
Yeah.
So some brilliant person actually in the military decided to abstract the problem. And they said, well, spray and insulation seems to work really darn well at closing off gaps in my house. So maybe we can take a similar concept and we can take some foam that, again, causes that compression, because what's really happening is that foam goes in and then it expands, and as it expands, it fills in the gap and creates pockets of air, all this other stuff, right? So if we do the same exact, and it causes pressure, if you actually were to look at the building, depending on the strength of the foam, it can flex various materials. Well, thankfully, your organs are actually relatively squishy. So flexing them is pretty easy, which is good, because what we're really after in this case is we want to put in a material with the right strength so that it causes that flexation to shut off the hemorrhaging. And then what happens is a surgeon will go through and they can remove the foam, and then through surgery they can take care of it. I'm not advocating people go out and take spray and insulation foam, by the way, and squirt it in their bodies to stop bleeding. I'm just telling you that that thought process is what caused the military to go through and devise a series of different plans that actually work incredibly well on people who have what used to be terminal wounds. And all that they did was they abstracted the problem, period. And that's what you should do with everything you do. So if I'm going through and I'm trying to find malware on a system, okay, or if I'm trying to figure out if you've been compromised, period, what I need to do is a very specific set of processes, and we can go over those at a later date. But the issue is very similar, has very few differences than how you secure the system to begin with, or how you should be troubleshooting and debugging on a day-to-day basis as a system administrator, and so on and so forth. The processes are very, very similar. And that's all you have to do with anything you're doing in life is don't look at, okay, well, how do I perform SQL injection? Look at, how do I perform injection? Look at, how do I abuse this input? I don't even care what the end results are. How do I abuse this input? And then once you start abusing the input, you can put your finger on what it is you need to do to make it do what it is you're after. But it's, how do I abuse this input? And most vulnerabilities come down to input injection. Most vulnerabilities are a failure to properly sanitize and validate input. It's last I heard, it was 90% of all vulnerabilities fall into that bucket. So if you prevent that, you literally prevented 90% of all vulnerabilities.
Yeah, that goes to say that you can't build a house without a structure. So, and in this case, you have to have some type of framework. So, whether it's malware analysis, whether it's application penetration testing, hacking, network penetration test, does not matter. They all kind of have the same processes and the same ideal. Like, so, if I'm a malware analyst or a malware developer, then more than likely that same strategy, especially when we're talking dynamic, static, whatever that may be, that's still carried along from other areas. Same with application penetration testing. You still have to do that same idea, dynamic and static analysis. Whether it is IoT, same idea, mobile, all of those kind of ideals
Right,
drag, into these different areas, which has been great for me because it's the same idea.
right. The only thing that
You know,
changes are the tools.
right. The tools change, and maybe in some areas you have more tools
Right,
that you can leverage in other areas. But that mindset has helped me be able to be good at everything I do because I can carry that same processes over to other areas.
right,
And it doesn't mean that we're just talking about one in general at this moment. I was just talking about security, but that could be whether you're making music,
right.
different stuff that the way you're going to solve this problem is going to be similar. It's just being able to, translate that no matter what you're trying to do. And especially if it's security, if you feel like, you don't have any way to get in or in other different field, if you're in one field already, you can translate with the skills that you have or skills that you have into other fields.
Yeah,
You just have to be able to see the pattern. And that's
exactly.
what we're acknowledging,
Exactly.
pattern.
That's exactly right. It is all pattern matching. And that's all that you do all day throughout the day. Subconsciously, you don't even know that's what you're doing. That's what your brain is doing, period. And it's interesting because, to give another example, so I've helped build supercomputers. So if you think about it, a massively parallelized distributed system, right? So you've got a whole bunch of CPUs or GPUs, depending on what it is you're using, and they're all working together. And so a lot of people, they're like, oh, this problem is so complicated. I have to think about how all this stuff is going to communicate and synchronization and all this other stuff. That's great. But let's use our heads for 30 seconds because it's actually a really easy thing and the problems have all been solved already. What is the difference between a motherboard and all of the components on it and a network and all the components on it?
It's really similar.
Yeah.
And unless you're going to start talking about those topologies, but they're really similar, and and especially the way they run, they all have to connect. So you can see those pathways on the circuit board. All right, there are
Yeah.
buses.
That's exactly
Same
right.
thing.
Exactly.
Yeah.
There are buses. It's the same thing. That's exactly right. So there's no difference when designing a well-designed proper network as compared to when designing a well-designed proper, say, motherboard. There actually really is no difference. And,
Yeah.
and people are like, well, what about security? You know what? You can put in proper gates and stuff like that on your hardware too. Most people don't, but you could.
Yeah. Yeah.
And what's the difference between working on an application that is multi-threaded or multi-processed versus working on creating an application that is multiple computers strung together? For all intents and purposes, it's the same thing.
The same thing. Yeah.
And
They're
the
both.
problems are
Yeah.
the exact same too. The exact same. You have jitter. You have network disconnects. You have the fact that you don't control everything. You have synchronization and communication. The problems are the same, and the solutions are all so insanely similar. And that's exactly what we're talking about here. Every single time, anything you do, you just have to learn how to bring it up higher and higher and higher. And you know what? If you're struggling to find a solution, take it up another notch. Abstract it yet again. Because there's no difference between creating an application versus creating a distributed application versus creating a massively distributed application. The problems are all the same. The only difference is maybe where your concerns lie. And that's really caused by you. Oh, well, I'm creating a video game, so I want to make sure people aren't hacking it. Well, I mean, people who are doing it for solo play don't care, right? Who cares if you cheat yourself? But in general, the actual technical issues are the exact same, and how to prevent cheating would be the exact same if you know what you're doing.
Yeah. I agree. I agree totally. Well, that's our time, everyone. Please subscribe to the channel if you haven't, and join us for the next episode of the Roniel and DaRon podcast show. I'm Roniel,
And I am DaRon.
and we're signing off. We'll see you next time.
Have fun.